We'll get started here. Thanks for joining us today at our webinar on cost of benefit analysis of lagoon screening. So I think this is kind of an apropos topic in a lot of ways right now, as obviously we've all heard about the toilet paper shortages that have occurred because people, I don't know, feel like they need to buy toilet paper as a result of the coronavirus panic. And you know, the big fear is that that lagoon operators are going to get inundated with flushable wipes. And so we'll dive into some of the issues with that as we go through this presentation. But I hope you find it interesting. So I'm going to talk just briefly about Triplepoint, who we are, what we do, for those of you unfamiliar. Talk about why screening might be a good idea, the types of screens that are out there, the cost analysis associated with, hey, if I was to buy a screen, is there a payoff on this screen over time, with a conclusion. So for you, those of you who maybe not are less familiar with Triplepoint, there's sort of three things that we like to think of ourselves as being unique, that make us different from any other company that's out there. First of all, we focus on lagoon systems. Lagoons are all we do. So when you, I like to say, you know, if you had a heart problem and you needed to get a heart transplant, right? Would you go see a general practitioner or would you go see a specialist? You would definitely go see the specialist, right? And I think the same thing with lagoons. When you're thinking about doing a lagoon upgrade, you know, are you going to go to the general practitioner or are you going to go to the specialist? And we're the specialists that can really help you get that job done. That's all we do day in and day out. Our focus, our goal, our mission is to help lagoons do it better. In that vein, we take a very, very tailored approach, you know, as opposed to how do we fit our technology, you know, take a cookie, as opposed to a cookie cutter approach where we're taking our technology and putting it on your site. We're looking for all the different infrastructure that you have to try to utilize that as much as possible to give you the most cost effective and long-term low maintenance solution. And the third thing is we stand behind and guarantee everything that we do. We have a 5-year process guarantee and mechanical warranty on everything we sell. So we are very, very much in the business of trying to give you a system that's going to work and it's going to stand the test of time, because we want you to be a happy customer so we can go get more happy customers. So in that vein, you know, we've developed a number of solutions over the years to help lagoons meet process challenges. So we started out in aeration. And we've been, I think we have over 5,000 aeration units in the field. I'll touch on that technology here in a minute. Then we started getting into ammonia removal with our nitrox system. And then we started seeing a need for denitrification after you did the nitrification and ammonia removal. So we developed our nitrox plus D, and then finally our Phosbox system, which is a phosphorus filtration system. So no matter what your compliance requirements are, we are able to help in terms of all these nutrients in BOD and TSS and all the above. So our latest product, and this is just two more slides before I jump right into this presentation. Just want to share with you this because we're pretty excited about our latest iteration of the Mars aeration technology. We're calling it the Aries unit, and it's the same concept as the Mars that we've been selling and have over 5,000, same exact technology, but we're just reconfiguring it and redesigned it to make it a lot better. So what it does is it combines a fine bubble diffusers here on the outside with a coarse bubble static tube in the center. And so what you get is you get efficient fine bubble oxygen transfer, but you also get very, very good mixing through the static tube. So this beautiful, colorful side of the slide here on the right shows you how the water moves around the unit, right? So you can see with these arrows that the static tube is creating an airlift effect where it's pulling water from the sides and pushing it towards the surface. And so what that helps to do is get some of the solids that are maybe liquefied or lighter and fluffier and get them in the water column where they get access to oxygen and break down aerobically. So we've done a number of studies on this, and you might have seen from some of our previous webinars where we looked at in situ lagoon sludge removal. And what we found is that we've done about 4 or 5 different studies now where we get about 45 to 50% sludge removal just by putting the Aries unit in the water and creating more mixing within the water column. So it really does help to limit sludge, which when we talk about adding lagoon screening, one of the big factors is looking at sludge, because sludge is the Achilles heel of a lagoon system, and it's also the thing that costs the most over a 20-year life cycle to remove. So if you can minimize that by aerating it, great. So just some statistics to throw at you in terms of the Aries. We did clean water oxygen transfer testing on this unit, and we saw up to 2.4% of standard oxygen transfer efficiency per foot of submergence. So just to give you a relative sense, a typical fine bubble system for a lagoon will be 1.9 to 2% per foot of submergence. So we really saw about 30% better oxygen transfer efficiency with this unit, which we were really excited about. The second part of this is we got about the same amount of gallons per day moved by the unit that we had with our Marge system. So they're the same technology, they're just a different configuration. So we saw the exact same amount of mixing, which was really good because we really want to maintain that mixing. Third of all, we were able to reduce the weight of this unit by 30%, and I'll explain how we did that in a minute. But the general thought there is it just makes it easier to install and then easier to pull up and maintain when you need to do that. So just briefly, some features for you of the unit. A couple things that I'll highlight. One is that we reduced the weight, as I mentioned, and we did that by moving to a cast iron ballast. And what cast iron does is it actually has a higher density than concrete, which is what the typical ballast material is used. So you need less weight to weigh the unit down and keep it ballasted on the bottom. But it's actually heavier in the water, pound for pound, than concrete. So we were able to reduce weight while also increasing our safety factor when it comes to the overall ballast, which is really cool. The second thing is we moved to this quick connect concept here. So our old unit had threads, and a lot of fine bubble diffuser systems have threads where you're threading the diffusers into an air manifold of some kind. With our new design, this is a quarter turn quick connect. So you put it in the socket, you turn it a quarter, it snaps, it seals. So it makes it very easy to both to install the diffusers, to maintain the diffusers, and to move this unit around the site, because you're not going to screw these diffusers on until the absolute last possible minute when you're about to plunk it in the water. So it really increased the overall user effectiveness, the user friendliness, I should say, of the unit. Another thing that we did on this unit is we moved to more of a silicone membrane. And the benefit of the silicone membrane is that it has a longer useful life than the typical EPDM. So a typical EPDM membrane may only have 5 to 7 years of useful life to it, or between cleanings. With a silicone membrane, it has 10 to 15 years. So it's almost double the amount of useful life. And for us, you know, being a lagoon focused company that's really focused on lagoons, we know about lagoons is that they don't have the manpower to operate them. So you really don't want to have to pull up and maintain the unit. So we went out there and looked at lots of different types of membranes and came to the conclusion that this was the best, most efficient, long-term, low maintenance membrane that's available on the market. So we're excited about this unit. We've got units that are shipping in June 2020. We've already got a bunch in the field already. Same technology as the Mars, just a different configuration. So if you guys are interested, please do reach out. So as I kind of mentioned at the top of this presentation, you know, I mean, we have a Facebook group, and you know, we've been posting on the Facebook group and seeing a lot of comments from operators out in the field that are really concerned about people starting during this crisis that we have with the coronavirus, sitting at home and using these wipes and just flushing them down the toilet. And you know, any operator of any wastewater plant is going to know what this is like and how much of a nightmare this is, right? Because most of these wipes that they say are flushable are not actually flushable. So the problem with it is that, you know, these materials don't break down easily, And so when they get in the pipe, unlike toilet paper, where they'll basically, get it incinerated or broken up into lots of little pieces through a pump, these ones have fibers that are attached together and just don't break down, right? And so what happens is these things end up finding their way into your lagoon and down into your sludge blanket. And when they find their way to your sludge blanket, they can help decrease treatment and cause aeration problems. And then also shorten the life between removing sludge in your lagoon, because these fibers are a lot more complex and take a while to break down in the sludge. So I'll go through a little bit of each of these concerns in detail. So when we talk about sludge, there's really kind of two forms of sludge, or two components to it, right? There's the grit and the non-organic material, sand and grit and things that find their way into our wastewater streams. And then there's the complex organics, right? And so I think the wipes are more in that complex organic type of range. They're not dead biomass, dead bacteria or algae, things that want to break down really easily. They're more in the range of things that don't want to break down as easily, but will break down over time if you leave them long enough, right? And so the concern here is that while lagoons are designed to store sludge, that most lagoons are designed with about 2 feet of sludge storage in them, that they won't be able to, these complex organics are going to build up faster than the typical 20-year life cycle window of a lagoon in terms of its sludge storage capacity, right? And so why is that a problem, right? Well, it's a problem because, as I mentioned earlier, the Achilles heel of a lagoon system is sludge, right? It's the Achilles heel, and it's one of the main benefits at the same time. The benefit is you only have to handle solids once every 20 years. The downside is if you let those solids accumulate too much, you end up with a whole host of issues, right? Including Benthal feedback, pH issues, floating, popping sludge with odors usually are accompanied by that, algae overgrowth, reduced treatment, and low dissolved oxygen. So how does that happen, right? Well, there are normal sludge accumulation rates within a lagoon, and then there are abnormal sludge accumulation rates. And the flushable wipes have the ability to create an abnormal condition because those solids don't break down very easily. So this is a table that we pulled from Steve Harris's Lagoon troubleshooting guide, which is excellent, by the way. You can get it on USA Blue Book, where it talks about studies that have been done about the normal accumulation rates based on climate, right, over a period of time, right? And you can, some of these are conservative, and most of these are very conservative numbers, but most of the sludge storage requirements, depending on where you're at, if you're down south, obviously the weather is warmer, your sludge is going to stay warmer, it's going to break down faster versus being up north, right? In Canada, where it gets colder in the wintertime, and half the year you get very little, if no, sludge digestion going on at the bottom. And in any of these cases, whether it's you're in the south, you're in the Midwest, you're in the north, if you don't have if you got much more, a larger proportion of your sludge is from flushable wipes, these things go right out the window, right? And this accumulation builds up faster, right? And there's no question about that. The question is, how much of an impact is this going to have and when? So one of the first things that you see when you get sludge accumulation that becomes very obvious, right, is that sludge accumulation will start to reduce your overall hydraulic retention time, right? So what it does is it displaces water within the water column. So this shows you kind of a typical lagoon cross section, right? You've got sludge accumulation on the bottom, and typically, like I said, most lagoons are designed with about 2 feet of sludge storage in them, right? then you've got the rest of the water column as it goes up here, right? And so the bigger that this sludge accumulation zone is, right, the less overall treatment volume you have within your lagoon, right? Because that sludge starts to take up a greater and greater portion. So in very extreme cases, I've seen situations where, you know, they've got sludge accumulation on the bottom and they get lower overall treatment where, you know, they're putting out 100 BOD and TSS out of their lagoon. They're only getting, let's say, 75% removal in some cases, or 80% removal of BOD when they're designed around 90 or 95%. So if you let sludge accumulate for too long, that's the kind of things that happen, and that's what the flushable wipes have the potential to do over the short to medium term in terms of building up on the bottom of the lagoon. The second thing that can happen, and tends to happen, is you get what's called a Benthal feedback, right? And Benthal is sort of a word that's derived from Latin, and it basically means coming from the bottom. And what this means is, and this gives you an example here, this is the lagoon facility that we worked on in Iowa. This is before we put our system in. And they had 2 sampling points, one here before their polishing pond, one after their polishing pond, right? And they, you know, were taking samples out of here for ammonia. And they were comparing their influent ammonia, basically their ammonia coming from their second cell going into the polishing pond, and their effluent ammonia. And as you can see here, there were some cases here where that right here, for example, and right over here, where their effluent ammonia was actually higher than their influent ammonia. And what happens in those cases is that the sludge on the bottom, right, that's deprived of oxygen, starts to break down anaerobically. And as it breaks down anaerobically, it releases ammonia. And it can release phosphorus, and it can release BOD at times, and TSS. And so it becomes a big problem potentially, and this is not even a very extreme case, where you get situations where you will be in compliance for 80% of your system, but you have to go through this polishing pond because it's on your permit, and you find once you get through that polishing pond that you're out of compliance. So it's definitely something that can happen. I've seen happen more than you would think it would happen, and it's largely as a result of sludge. One of the things that sludge can do when it breaks down anaerobically too is it can create septicity, and septicity can raise your pH levels, or lower your pH levels rather. And when your pH levels get down to a certain level of acidity, the bugs don't like that, right? So your good bugs, your BOD consuming bugs and your nitrifiers don't want to be too far and extreme in terms of acidity. Now, from a municipal point of view, you see this less often where you see the septicity occur than you do, let's say, in an industrial system that might be overloaded by sludge and loading, but it is something that happens. And when this happens, like if your lagoon goes septic, you got a major problem on your hands. And it's not good. Your treatment basically can drop off a cliff. Sludge buildup also has the potential to cause a low dissolved oxygen condition. So we worked on this facility here. This was in Parsons, West Virginia. They had old surface aerator system out here that you can see wasn't working particularly well when we got there, and they had a lot of sludge accumulation on the bottom, right? And so the thing about that sludge is a lot of it is undigested BOD, right? And so when you think about what the oxygen demand, right, of a lagoon is, you're looking at the oxygen demand from the influent BOD that's coming into the system, and then plus the oxygen demand just to keep a residual DO within the water column, right, just to have a buffer. But we often don't think about the oxygen demand that comes from sludge, from undigested BOD that's sitting on the bottom itself. And so, you know, these 3 things together can lead to a low BOD condition. So this, you know, the gist of this slide is that, you know, you could be overloaded, and if your lagoon is overloaded, it can be in part because that sludge on the bottom is consuming oxygen, lowering the dissolved oxygen levels, right? Because there's undigested BOD, and it can create all sorts of issues, right, within your treatment process, including low BOD, odor, and popping sludge, as you can see here. So this is also Parsons. This is after they had their spring turnover and they saw a lot of popping sludge. So this right here is straight up floating sludge. And what happens is that sludge is breaking down anaerobically on the bottom, and as it breaks down, it traps the sulfur dioxide that's produced, and the methane gets trapped underneath the sludge, and it actually floats it to the surface. It's pretty rank. I was actually out in this lagoon, about 10 years ago or 11 years ago, floating around, and I can tell you that stench was bad, right? And usually what happens there is you obviously end up getting a lot of odor complaints, and you also don't see very, very, very good treatment. So, you know, enough about all the, you know, scary stories about having too much sludge. I only impress those things upon you because it's all too often that I see a lagoon system call me that's having all these problems, and just can't, usually 9 times out of 10, these types of problems, all those things I just described, it because they have too much sludge. And we can help break it down with the Aeries unit, but honestly, there's other methods, and screening being one of them. So, you know, another sort of really obviously very important, aspect of this is that if these rags don't break down as quickly, right, then they're going to contribute to your sludge blanket, right? And if they contribute to your sludge blanket and they don't break down, then you're going to end up paying more to remove that sludge. So it could make up, you know, between 25 and 30% of your solids. You know, it's honestly, it depends on municipality to municipality and area to area. We have seen some lagoons which have a lot of ragging issues, other ones which have far less. And I'm not quite sure why that is, but it does seem like there's no doubt that it contributes to the sludge blanket. So this shows you here a lagoon system that we did rehab on that had, this is their sludge measurements within their first 2 lagoon cells. Average sludge depth was about 4.29 feet in cell 1 and 2 feet in cell 2. So, you know, those are pretty deep. That's kind of getting to the point where this is too much sludge for the lagoon to handle. So they really needed the sludge removal pretty bad. And this lagoon also did not have any screening at all at the front of it. So the more sludge you have to remove, the more cost there is. And I'll get a little bit more into the cost here in a minute. The other problem, the final problem that I want to talk about in terms of this, and this is actually pretty major, that if you have aeration, those rags have the tendency to build up and clog your aerators. So on the left-hand side, this is a picture of a facility down in Mississippi that we upgraded. It had a bunch of these surface aerators. This is their little surface aerator boneyard that they had on the shore when we showed up. It seems to be all too common that you see these kinds of surface aerator boneyards at these sites. And you can see within these surface aerators how the ragging right here was clogging up the impellers and clogging up the units, and that's just so common to see. On the other side of the page here, you see the submerged aeration units. This was up in Revelstoke, Canada. We replaced these units with our Aeries technology, and you can see as they pull them out of the water here, all the ragging that had built up on these units. I mean, just piles and piles of these rags. And it seems like the rags are pretty indiscriminate about building up on aerators, right? They don't really care. The aerators are going to move water around. They're going to bring water closer to them, and they're going to suck up these rags, and these rags end up getting clogged. At Revelstoke, as a matter of fact, they had such an odor issue there that it was major public relations crisis for the city administrators. And it was in part because of these rags. I wouldn't say it was in all the 100% of the reason, but it was in part because of these rags, because the aerators were not working as efficiently as they should. And so, the remedy to that is you got to get out on a boat and you got to clean these aerators. But of course, nobody wants to do that, right? I mean, I don't want to get on a boat and pull an aerator out of a poop lagoon and clean it from its rags. Let's be honest. But customers that are committed to keeping their aeration system operating properly can spend, tens of thousands a year on pulling these units up. Sometimes they'll hire an outside crew to come in. We have a service company that will do that for you if you're interested. Just reach out after this webinar, but it costs a lot of money. And then when those rags, the other part of the ragging on these aerators is when they start to build up on the diffusers, then the diffusers start to clog. And when the diffusers start to clog, they add back pressure to the system, right? And that adds back pressure to your blower. And then your blower has to work harder. You use more energy on your blower, and you end up having to shorten the maintenance cycle on your blower as well. So you end up having to maintain your blower more often. This was also something that we saw at Revelstoke when we replaced the system, that they dropped like 3 pounds of pressure as soon as they turned our system on, because they just took out all these clogged up aerators, right? So there is a maintenance cost to it and a maintenance nuisance to it. There's an energy cost to it as well. So it really, that's the big issue. So now let's move on to the technology portion of this. So Lagoon screens, right? What are we looking for? And for me, having talked to a lot of operators, and this being one of them right here, Dan Van Langen from the city of DeSoto, which I'm going to use as a case study, obviously during this presentation, he wants something that's low maintenance. He wants something that can be installed outside without needing a building. I mean, anytime you got to build a little building around something, it just adds a lot of cost to installing something. He would like it to work without the need for that. He wants, what the industry refers to as capture efficiency, which means, you want to get the rags out. You want to capture those rags and get them out. But, he doesn't want a lot of maintenance either, right? And I'll get into that in a little bit more detail later. But, the finer, the more it pulls out, the more maintenance you got to do on the screen. So you're getting that careful balance between getting the rags out while also, not creating extra maintenance items and wear items on your screen itself. And then finally, you want to be able to handle peak flows. Like any system, Lagoon systems or like any wastewater system, they're going to see a huge variability in flow, and you got to be able to handle it the best as possible. So the options. So I've been to a lot of Lagoon sites over the years, and what I tend to see are bar screens and perforated plate screens, the two types of screens. This is actually an image of the type of perforated plate, and I'll get into more detail in a minute here. So I'm going to go through the two different technologies, perforated plate and mechanical, and talk about the pros and cons of the types of screens that I've seen. So the most common you see with Lagoons would be a manual bar screen. If they have a screen at all, they're going to have a manual bar screen. And so you see here from this this image here, the water flows through a channel through these bars, right, which are spaced, anywhere between 3/4 of an inch and 2 inches apart, right? And then you've got to go out there every once in a while with this rake, and you got to rake up any rags and rake them into this basket here, and then unload the basket somewhere, right? And the general thought there just being, the guy gets out there, or, your operator gets out there once a day and does this, and look, I would say that while this is not really ideal in a lot of ways, you can see here an operator doing that at a Lagoon system, raking these bars. It's very inexpensive to put one of these in, right? There's no mechanical parts to it, right? It can fit in a channel, existing channel, if you have one. And it provides some screening, you know, and look, if it's this or nothing, I say this, you know. I think that you can, you know, worst case scenario, if the guy doesn't get out there for a couple of days, it'll end up just overflowing the screen. But, you know, this will do something, it'll help, but it's not really going to get a very good capture efficiency. So it's not going to take that, like it might only get 20 to 30% of the rags that are coming through, but 20 to 30% is better than nothing. Now, if you're able to, then you could go with mechanical bar screen. And so this can fit right into a channel. The bar spacing can be a little bit closer together, so you can get better capture efficiency, anywhere between 1/2 inch and 1.5 inches. It can be mounted vertically or horizontally. There's lots of different types of these screens, and it basically automatically cleans itself once it starts to get clogged up with rags. This is a bar screen. I'll show you a quick video here that I like. Hopefully that video comes through okay within the webinar here. But so you can see, like, this is quite cool because this cleaning mechanism essentially rakes everything off the screen right here, pulls it all the way up right to the top, and then there's a dumping mechanism here that dumps it into a trash can, right? And I actually like this screen design in particular because there's only one motor that goes with this, and that's just a drive motor that literally lowers that rake down, pulls the rake all the way up to the top, and apart from that, there's no other motors or shafts or anything else. So the benefit here is it's automatic, right, in terms of its cleaning mechanism. You have one drive motor associated with this screen, so it's, you know, not a lot to break, but still a motor is a motor. It can get a higher capture efficiency than the manual screen. But, you know, like any mechanical piece of equipment, you know, you're going to need to do some maintenance on it, right? And it has a relatively lower capture efficiency than the perforated plate screen, which I'll talk about here in a minute. I think the capture efficiency for getting rags out on a bar screen is probably sufficient. And so that's a good thing. And this can be a relatively cost-effective way of screening. But I'll move on to the perforated plate. So a perforated plate is kind of what it sounds like. It is a screen that has perforations that are quite small. 1/4 inch is kind of what you tend to see. And it can be mounted vertically, horizontally. It automatically cleans itself, like all mechanical screens do. It dumps the screens in a trash can. Some of these systems also have compactors that will, washer compactors that will actually compact the screening material to squeeze out any water and make sure that you know, that water goes back into the lagoon itself. But you don't necessarily need that for a lagoon system. But here's a little video. This is at the City of Pacific. We did an install of our aeration technology there last year, and this is the headworks they already had. So I went into the building and took a little video of it. But as you can see, like, that's down in the channel, and the perforated plates are cycling around and they're pulling up material. Now in this case, you don't see a whole lot of material that they're pulling up. Probably not a lot of high flow going on, but they will pull up that material and then come around here to the trash can and dump it right in here. It was pretty stinky in there, as you might imagine. So look, you can see it gets a lot of stuff out, which is great. It does require maintenance. You gotta, you know, take out these trash cans every once in a while. But it, you know, it's stopping that stuff from getting in your sludge blanket, which is kind of what you want, you know. So the benefit, you know, similar benefits to to the bar screen. You get automatic cleaning, this has the highest capture efficiency, so that's the main thing that's really good. There are several parts that you need to replace on this unit. There's the drive motor that's moving the screen. There's, depending on the type of unit that you have, there also could be a compactor component to it. Also, that will be another motor to actually compact the screening materials. You know, with the screen being smaller, you know, it has a higher potential of clogging and having issues potentially. So, you know, it's a nice screen, and this is what's called, it's not quite a perforated plate step screen, but it's kind of like that. This is actually a little bit more expensive in terms of the two perforated screens that I'm going to present on. It is a nice screen. It has less motors than the next perforated screen I'm going to talk about, but it is a little bit more expensive. So the second perforated plate screen that I'm going to talk about is this guy. So this is kind of an auger screen type, and the way that it works, actually I'll scoot forward here, is that you get this grinder right up ahead of it that grinds all the things coming in. Then it flows into this screen, which has a drum that's sitting in the channel here. And then the auger is basically cleaning the screen, and then this corkscrew is going all the way up to the top of the screen, where then it gets dumped into this trash can right here at the back. So what it does is it pulls the screenings out, and as it's pulling them up, it does compact them a little bit too, to try and get some of that water out of the screenings to get back into the channel and get back into your lagoon. Automatic cleaning, high capture efficiency, similar to the last screen. The downsides to this one is you do have this grinder ahead of it, which is one motor that's operating all the time, and then you also have a motor up here that from the auger side that is also running as well. So you've got these two moving parts that need to be maintained. You've also got these brushes that are here that also need to be replaced on this unit once every 5 years or so, I think, when I talked to this operator. And so that's something you got to pay attention to. So definitely a little bit of maintenance there. But, you know, this is really a proven screen. This one in particular was down in Tennessee, and this lagoon gets all of its waste from a nearby prison. And so obviously prisons are notorious for the inmates, you know, flushing everything down the toilet. So the screen was really important to make sure that none of those materials got flushed down the toilet, end up in the lagoon itself. And it's, you know, the operator likes it. He says it's been operating pretty well for a long time. So no complaints here, just a little bit more maintenance than some of the other screens that are available. So, you know, you got these screens. The question is, does this make sense, right? Is there going to be a payback from doing lagoon screening? And so this is a little case study. Again, I'm going back to DeSoto because we have sludge information because they recently desludged, and we can kind of see what those costs were. I also had costs for that desludging as well, what the bids came in at. And this is a 0.3 MGD lagoon system. It had 18 aeration units in there. Our aeration system, sludge was moved in 2018. So does the screen make sense for these guys? What kind of benefit from a cost perspective are they going to see? So as I showed earlier, they had a significant amount of sludge accumulation in their first and secondary cells. And you know, it was estimated that about 25 to 35% of those solids were actually rags or complex organics that couldn't be broken down, that were coming in from the collection system and could be removed by a screen. So their cost to remove sludge was about $245,000. So they had 410,000 cubic feet of sludge in cell 1, 135,000 in cell 2, 71,000 in cell 3. So a total of 617,000 or 618,000 cubic feet of sludge. So that's about 40 cents a cubic foot, or if you want to amortize that over 20 years, that's $12,250 a year. And I think that's a cool number to look at because a lot of people that have lagoons don't think about it in the sense that $12,250, that's an operating cost that you're not seeing on a yearly basis, but eventually is going to catch up to you when you have to remove sludge. And so it's really, I think, important to realize that while lagoons are great and they're the lowest cost thing to operate, you need to factor all the costs that are associated with a lagoon, and removing sludge is one of them. That's not, this still, lagoons cost effectiveness still beats the pants out of a mechanical plant, no question, if you've got the land to build it. But looking at it that way, it's important to put the money aside in order to do this desludging when you need to. So if you looked at the cost of these flushable wipes and you said, okay, well, let's say I had to remove sludge 5 years early, right? And you consider that, it's $12,250 a year, right? That's costing you, if you have to do it in 15 years instead of 20 years, it's costing you $61,000 a year. So for that period of time. If you looked at it from the perspective of 7.5 years or 10 years, obviously that number goes up. So the lower that, the increased amount of frequency that you have to desludge, the more money it costs you. And as such, there is a cost savings by being able to extend the amount of time between when you desludged today versus when you're going to have to do it 20 or 25 years from now. And so I felt like 5 years was a pretty reasonable number to use, that, if you had a lot of rags coming in, that it would probably, shorten your desludging cycle by 5 years. And if it did that, that would cost you about $61,000. So when I look at maintenance, I'm assuming in this case they had aeration in their lagoon. So I'm sitting there and I'm saying, all right, well, every 5 years or so, if you had lots of rags building up on your aerators, you need to get out there in a boat and you need to pull these aerators up and clean them, And so, based on the number of aerators they had and the equipment and mobilization costs of bringing our crew in to do it, we felt that was about $16,000 over 20 years. And so it'd basically be 1 day of our crew's time every 5 years to come out and do that. So it's, the cleaning is, actually a little bit less than $5,000, which is, pretty cost effective when you look at, the maintenance and labor time that you can get. And even then, that's $16,000, dollars every 20 years that you've got to just for cleaning your aerators. So, I think that when you compare that to having the screen, yes, you do have to do some replacement of brushes and maintenance of the drive motor and such, but this is 10 years showing you the replacement of that drive motor right here. It still costs you a lot more from a aerator point of view to keep your aerators working than it does to maintain something that a screen that's in a screening building and on shore. So I think one thing it kind of comes back to, and I use this analogy a lot when I'm talking about looking at aeration. And if you have surface aerators now and you are placed to replace your surface aerators with a diffuse system, right? The benefit of a diffuse system, like our Aries unit, for example, is that now all the motors that were on the water, right, your surface aerators, are now on shore. And so all your maintenance items on shore. Same thing with the screen, right? Instead of having your maintenance be on the water in terms of your aerators, if you put in a screen, you then make that maintenance to be on shore, right? And anytime you can move maintenance from the water to shore is always going to be a net positive for operations and maintenance costs. And that's what we're seeing here in this projection. Then I looked at power savings. I looked at, like, you know, one thing that I haven't talked a whole lot about, but I did mention it earlier, was that these screening materials, these materials that you're taking out with screening, have BOD in them, you know, and it's not just the complex organics or the fibers that are the actual fibers that the rags are composed of. It's stuff that gets caught in those fabrics, right? And so when you remove rags from your wastewater system, you naturally remove BOD with them by as much as 25%. And so we have seen this bear out in the data, where you put a screen in, and all of a sudden, you know, your aeration just starts to work better. Not only because it's not getting clogged, but because there's less BOD in the system. So you end up having higher DO, and you can potentially cut back on horsepower. So I looked at this from the perspective of, if you could put a screen in and said, I can cut down on 25% my horsepower usage by putting a VFD or turning off an extra blower, because I don't need it, because I'm taking out some BOD naturally with these rags, then that saves a lot of money over 20 years. You know, that saves $3,500 a year, $84,000 over 20 years, which is pretty significant. So when you pull all these together, you get about $12,500 in O&M savings, right? Or $100,000 over 20 years, right? So it's not hugely significant, but it does help improve treatment, right? And this is a good example right here of our system here at DeSoto. You know, like, as soon as they could be able to implement better treatment, they were seeing significant, they removed sludge, everything else, they saw significant reduction in their BOD and TSS and ammonia through their entire system. So that's huge, right? And so $100,000 might not be, you know, when we take that $100,000 and we put that with, you know, the cost that you can maybe extend or at least not shorten the life of between your desludging, you see that a screen would probably have about a 10-year payback for the city, which is not awesome, but it is something, and I think it's probably worth it when you look at the long-term grand scheme of things, because now, you know, instead of having to, you know, now you've made your system a lot easier to operate, and you made your system a lot more reliable, and you made your system put out better treatment numbers, right? And so the more you can do to improve on all that, the better off you are as a city, the less chance you're going to violate your permit, et cetera, and so forth. So, you know, this was just one analysis that I did that I thought was really interesting, that I thought, you know, played out, and that seems $100,000 implementation cost, so about $70,000 for the screen, about $30,000 to put in place, depending on, obviously, largely depends on whether you have a channel currently or you need to add one, but it's something that I think is worth considering for your circumstance if it makes sense. So just before we move on to questions here, you know, rags, really, I mean, I think one of the big concerns is that you end up building up sludge and you get all those issues associated with that sludge buildup. And that's odor, algae, higher BOD, effluent, etc. So sludge really needs to be paid attention to, and rags is one way to manage that in an active way. It can also, screens can also help you minimize the amount of maintenance on your aeration system, make your whole, remove BOD so that your whole system just operates better. So, and eventually it'll pay for itself. There's no doubt about that in my mind. So I hope you guys enjoyed that, and now I'll take some questions. Somebody asked the question about the sludge accumulation rate and whether it's based on this, the area of the lagoon. It is based on the total amount of surface area you have in your lagoon. So it's obviously, if you have more surface area, let's say if you're deeper, for example, then you're going to have relatively less surface area, and you have the potential for those solids to accumulate on the bottom and not get as much access to oxygen because they're further deeper in the water column where there's less oxygen typically without sufficient aeration or mixing. And so, sludge accumulation rates are based on a lot of things: weather, depth, surface area, etc. And it depends on, all these things come into play. And so the literature is kind of helpful to give you a ballpark, but even then, again, like I said earlier, some municipalities have lots of issues with rags. Some other ones have less issues with rags. So it really kind of just depends. Sorry to give you not a concrete answer, but that's kind of the way it is. Does Triplepoint manufacture these screens? We do not manufacture screens. We have over the years kept an eye out for different screening options that are on the market, and we had considered for a time to potentially, OEM a screen for the Lagoon market that we felt was suitable. And we did find one screen that we were maybe interested in doing a pilot on, if we could get some partnership with a municipality that'd be interested in doing a pilot on it. But it's essentially a bar screen that we saw that we thought would work well. It looked pretty simple. And we would want to definitely test it before we go out and try to sell something like that. So we do not currently sell screens. What is the rate of clogging of the static tubes of flushable wipes? So the static tube, one of the things with the Aries unit that we looked to do to redesign it was is we tried to make the design more clogging resistant, because as any aeration system will get clogged, the static tube can also get clogged. So our experience has been, here, I'm just going to pull up the, so our experience in our previous design right here, we used to have a tether point here and a tether point here, so on either side of the static tube. And what we used to see is that rags would not clog around our diffusers as much as they would clog and build up right around these tether points here and here. And so the good news about that is that it seems to not impinge upon the operation of the aerator as much. And so that's nice, right? But obviously it's still not ideal. This tube right here is 100% open, so there's no catch points within the actual static tube itself to clog it. But what we've done here with our new design is to put this pole coming from this down the center of this tube, which is concentrically going upwards, and our hope is that we won't catch as many rags because of only having one tether point and having that tether point be right where the coarse ripples come out, so that essentially that those coarse ripples will then scour this connection right here and eliminate or limit the amount of rags that'll build up right there. But I mean, our overall experience has been that any aeration system is going to be affected by rags. It's generally speaking, if you don't have too much sludge accumulation, it's not a death knell for the Lagoon. The Lagoon will keep working, our aerator will keep bubbling. May not be the most efficient aeration that's out there, but it's still going. And we haven't had any issues where our aerators have been so clogged that they have not been able to get the job done, right? But it is absolutely 100% a nuisance for absolutely any aeration system that's out there. And it's really, I'm not going to sit here and tell you that I have data to say that the Aries is better than any other aerator from a clogging with rags perspective. All I can tell you is we're trying to do our best to minimize it by designing the system correctly and in a certain way. So do we recommend screens be located in a building with a cold weather climate? I think it depends on how cold the weather is in your climate. They do make these screens with heat tracing, so it is possible that you could put it outside, but it just depends. I think if you're in Canada, you know, or somewhere real far north, you might need to put it in a building. Wheel facilities, which install Aeries diffusers, see a reduction in sludge buildup similar to that which is being touted with the newer Aeries diffusers. Yes, so the Aeries and the Mars from a mixing point of view are the same. They're identical. We've done studies where CFD modeling studies, computational fluid dynamic modeling studies, and we've done the Mars in the past, and we compared it to the Aeries. And from a mixing and overall pumpage and turbulence perspective, they do the same thing. We're 100%, you know, the Mars units actually are the ones where we've done most of our studies in terms of sludge removal, and we've seen about 45% sludge reduction of the volatile solid component of that sludge within the systems that we've done studies on. You know, either one, they're both great technologies. We're just doing the new and improved when it comes to the Aeries. The previous research table you presented did not take area of lagoon into consideration. How many centimeters a year? Yeah, so again, there are some calculations for this. If you want to email me later, I might be able to send you some resources on how to calculate the amount of sludge accumulation within a lagoon over time. But again, it's highly dependent upon temperature and other factors. And obviously the flushable wipes at this point might render a lot of those studies done previously obsolete because they were not done at a time when flushable wipes actually existed. Have you heard about cheaper solutions being developed for sludge removal? So we actually did a webinar on in situ sludge removal, where we looked at you know, we looked at basically bioaugmentation, which would probably be the most cost-effective approach to reducing sludge within a lagoon. If you want to go to our YouTube channel, you'll be able to watch that presentation. It goes into that a little bit more detail. I'm going to take about 3 or 4 more questions, and then we're going to close this down here. It's 1:58. Would a coarser bar screen followed by a more fine screen make any sense, cost benefit? Potentially, if you had a manual bar screen ahead of a finer screen, I could see how, you know, the manual bar screen could get rid of some of the rags, and then the finer screen could, you know, kind of take out the balance and maybe not work as hard because of that. I've never seen that before, but it's possible. For the static tube installation, are there any concerns about corrosion of the cast iron pad in this tough environment? So our cast iron bases are going to be coated with the, you know, it's going to be a coated cast iron base. So we're going to use a coat. We are using a coating that is going to prevent that any corrosion from occurring. Do you state what do we think about the possibility that the Aeries base will get stuck in the mud, make it difficult to remove the unit? I think, will the Aeries get stuck? It's possible. We do find over time that, you know, the units themselves will kind of get stuck down there, and we found that with the Mars as well. And, you know, it does come up, you know, if you use the proper equipment, you can pull it out. 9 times out of 10, that doesn't happen. There are occasions where if for whatever reason there's a lot of, you know, sludge or, you know, different things that are down there, that it's possible that it could get stuck, but most of the time we find that the units come up pretty easily out of the bottom. In part because we're creating all this mixing around the unit, so it's not going to bury itself in sludge because it's constantly moving that sludge and moving it away. And so what we often see when you pull down a lagoon is you see almost like an area around the unit where there's very, very little sludge, almost like a very, very, very shallow crater in essence, where it's sitting on top of the clay liner, and then everywhere else around it is pretty open and sludge free. And so, usually that's creating a situation where it's not going to get stuck. And we've done this in lagoons with up to 10 feet of sludge in them. I haven't heard about any reports of there being any issues with getting them out. So I'm just going to take one more question here. Would there be any benefit to installing a makeshift scum or sludge pumps to recycle wastewater from the second or third cell to the primary, especially if you have a deeper primary? Then it may be cheaper to just desludge the primary, and anaerobic degradation of organics may increase. So recirculation in general for any lagoon system is always a good idea. It does help improve treatment. We've seen it help improve treatment up to 30%. So, if you're going to create an anaerobic area, that's fine. I think you got to be a little bit careful, because if you get too much sludge, then you start to see a lot of the issues that we were talking about earlier with septicity, odor, popping sludge, etc. It certainly can help to move all the sludge into one place, but I think that sounds like a really good idea, but it's kind of hard to guarantee as well. So I'm going to wrap it up here. Thank you guys for joining us. Like we said earlier, like we're going to plan on doing more webinars, since everybody's sitting in the office now and not able to, because of the social distancing associated with the coronavirus outbreak. So if you guys have any requests for webinars, do feel free to email after this or put it in the comments here. We'd love to do more webinars. We like doing webinars, and we hope you enjoyed this one. So thank you very much, and have a great day and stay strong, and hopefully we'll be getting back out and doing more lagoon work here in the near future.